Hello everyone, so in this video, me and my teammates will explain about Kirchoff's law. So firstly, what is Kirchoff's law? Kirchoff's circuit laws are two equalities that deal with the current and potential difference. In 1845, Gustav Kirchoff first announced Kirchoff's laws, which allow calculation of the currents, voltages, and resistances of electrical networks.
CL, which stands for Kirchoff's current law, states that current entering the circuit is equal to current exiting the circuit. Therefore, I in plus I out equals to 0. In finding out the current, we see the arrows that show the current's direction into or out to the node. In the picture below, we can see that I2 or current 2 is the current entering the node, and I1 and I3 are the currents exiting the node. Therefore, we can conclude that I1 plus I3 equals to I2. Here's the example question. You may pause the video to think of the answer. The answer for this question is D. According to KCL, the currents entering the node is equal to the currents leaving the node. Or we can say, the currents leaving the node equals to the current entering the node. In the picture, we can see that the currents leaving the node is I1 and I5. While the currents entering the node is I2, I3, and I4. Therefore, I1 plus I5 is equals to I2 plus I3 plus I4. Kirchoff's second law, or KVL, which stands for Kirchoff's voltage law, states that voltage entering a circuit is equal to the voltage going out from the circuit. Therefore, V in plus V out equals to 0. From the picture below, we can see that the AMF V is equal to V1 plus V2 plus V3. Here is an example question of KVL. Pause the video to think of the answer. The answer to this question is A. Using KVL, we find V1 by looking at the loop 1. Therefore, 12 volts minus V1 minus 8 volts equals to 0. And so V1 is 4 volts. For solving V2, we look at the second loop, so 8 volts minus volt 2 minus 2 volts equals to 0, therefore V2 is equals to 6 volts. Here is another example question of KVL. Pause the video to think of the answer. So the answer to this question is A. Using KVL, we can find the total current by looking at the first loop. Therefore, 70 volts minus 5I minus 7 times I minus 2 equals to 0. If you are wondering where is the I minus 2 from, as we can see, one of the current exiting the node is 2 ampere. And since current entering the node is equal to current exiting the node, we can conclude that I total equals to 2 ampere minus the other I exiting. So the other I exiting equals to I total minus 2 ampere. And from the KVL equation, we now know that I total equals to 7 ampere. Now we have to find R on the second loop. Still using the KVL, 7 times I minus 2 minus 2R equals to 0. And since we already know that I total equals to 7A, therefore, I minus 2 is 5 ampere. So from that equation, we now know that R is 17.5 ohms.
Now, let's sum up everything. The summation of current entering the node is equal to the summation of current leaving the node, also called as Kirchoff's current law, while the sum of the applied voltage is equal to the sum of all voltage drops, which refers to the Kirchoff's voltage law. And this is the end of our video. Hope you enjoy and understand Kirchoff's law. Thank you.